All right, hello everyone, this is Mr. Crozier. I want to go over some of the problems. Probably the number one question I had was on problem number 2. We have this number, which is the complex number 3 minus 7i. So if I were to graph this, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, negative 7i. It's that point, I like to draw it as a vector, but it's that point. Well, if we want to put it into a trigonometric number here, we have to do two things. We have to find the radius, which is just a squared plus b squared square rooted. So the radius, the length of this is root 58. So that's how far this is. But then we also want to talk about what degree this is. Well, it's past 0, it's past 180, it's past 270. So it's between 270 and 360 degrees. However, if you look at it, a lot of times they're going to ask you to put it in terms of radians. So if I go to my calculator and if I do that, you want to make sure you have this memorized. Inverse tangent of b over a, inverse tangent of b, which is negative 7 divided by 3. There's that, but let's see what mode I'm in. I'm in degrees, so let's go ahead and switch it to radians. And it is a drop down of negative 1.5. So if I drop this down, it is 1 radian. It was, what, negative 66 degrees. So it's 360 plus negative 66.081 degrees. So it's about 293 degrees, which is what it looks like. But however, I'm going to do that and drop it down from 2 pi. So that's the number we get there. So we want it in radians. It's just a conversion between radians and degrees. So you want to make sure you memorize those two little bits of expressions to find the r value, which is here, and we just put in the angle there. Now, if you want to check this, right, you could just go root 58 times cosine of 5.117, and there's that number 3, and square root of 58 times sine of 5.117, there's that number negative 7. Again, they're rounded, but you can always check that. You can just distribute that in there and check it. That may be a good thing to do on the test. If you don't remember how to convert it, just go back and check it if you have a calculator. All right, other questions that people ask for, number 30 right here. To find this one, the property of logs say if you're adding two logs with the same base, you can just multiply them. So this is just x times x, which is x squared. X times this is 2x. And then this step here, I took it from the world of logs to the world of exponents. 2 to the third is equal to that. And then from there we just solve it. And again, extraneous, remember extraneous, you can't log a negative number. So if I put in negative 2 there, watch what happens if I try and log a negative 2. It does not work. So if it makes your logs negative, it's extraneous. Problem 37, someone asked about here. 37, a car is continuously decreasing. Well, once you see continuously decreasing, you can use this formula there. That's the continuous interest formula. 0.17 goes there, 12,000 goes there, times that by 0.35 is 42. And now we can take the log of both sides, which will drop this down. And finally, we just take the log, or natural log of 0.35 divided by 0.17. Someone asked about 37. A little bit more complicated, but the steps are just the same. We can put the 850 there, the 1,000 here. And what I did is I just cross-multiplied. I multiplied this one over and I divided this one over here. So this went up there, and then the other side I cross-multiplied that down there. And then now we can just go ahead and take the natural log, which drops this down, and divide it out. You get 31.65. And again, this is a great one to check. You can just go ahead and plug that in there and make sure it checks out, make sure it works. All right. There's that number when I divided it, that 1.17. If I multiply that over and divide that over there. 38. You need to make sure you know this change of base. Let's say I have this problem here. Well, everybody knows the answer to this is 2, right? Because it takes an exponent of 2. But if you didn't know that, you could just go the log of 100 divided by the log of 10. That will also give you 2. So if you have log of 5 to 20, well, log 20 divided by log 5. And again, you always want to check this. 5 to the 1.86 power does get you back to 20. Just change this one to the exponential form, and you can do the math. 39, same deal. We have plug in 8 there, plug in 300 there, and then we just do the steps. And again, the main step is this arrow right here. If you take the natural log of the left, you have this, and if you take the natural log of the right, this exponent comes down, and now you're taking a natural log of e, which is just 1. So that's why a lot of times we don't write that there, because it's simply 1. It doesn't change the answer. 41, you can bring this down. 2 times 3 is 6. Log 7 here, well, this is a 2. And again, if you forget that log, log 49 divided by log 7, it's 2. All right, a couple more. 55. 55, if you're looking for the vertices of an ellipse, well, first you have to plot the center, and the center, so I converted it to this right form, and then the center is here at 3, 1, and then I go, vertices are in the largest direction, so they're in this direction. I go up 6 and down 6 from here. So from here I move up 6, which would be way up there, and I move down 6, which would be way down there. Those are my 2 points. Also had a question about problem number 70. On problem 70 right here, this is the difference quotient. We take this right here and we run x plus h through it. So I have 4x minus x squared. 4, this is now my new x. So now instead of saying 4x minus x squared, it says 4x, which is 8 plus h minus this squared, and then minus 32. I just found this by plugging in 8 there. 4 times 8 minus 8 squared is negative 32. If you do the math, the constants go away. Now you can divide by h, and you have that. All right, hope this helps. If you have any other questions, try and see me before the final. Otherwise, good luck. Study the answer key. Go back, look at your notes, rewatch any of the videos, and good luck.